The large block in the middle of the periodic table is home to the transition metals, including well-known metals such as iron, copper, gold, and mercury. Other more unusual transition metals include scandium, niobium, and ruthenium. They all have similar physical and chemical properties. Transition metals are much less reactive than the metals in groups 1 and 2, so in general the transition metals are more useful. But all metals have the following physical properties in common. Metals are hard. Many tools are made from metals because of their hardness. Metals are shiny, so they're widely used to make decorative items. Metals are malleable. They can be hammered and bent into different shapes, resulting in these fine items of jewellery. Or this huge modern sculpture. Metals are ductile. They can be drawn into wires, again making them useful in jewellery and construction. Metals are strong. The metals in these bridges have good tensile strength for supporting heavy loads. Metals conduct heat. Thermal images of a saucepan on a hot plate show that heat energy is easily conducted through the metal pan. Metals also conduct electricity. Place any metal in a circuit and it'll allow electricity to flow. Most metals have high melting and boiling points. A tungsten filament has a melting point of over 3,000 degrees Celsius. Metals are also sonorous. This means they produce a sound when struck. Alloys containing the transition metals copper, nickel and zinc are used in coin production. A mixture of metals is used because it's stronger and harder than pure metal. What other properties make metals suitable for minting coins? Some transition metals can be used as catalysts to speed up chemical reactions. The transition metals platinum and rhodium are the catalysts in catalytic converters. These speed up the chemical reaction between carbon monoxide and nitrogen monoxide produced in engines. These polluting gases combine to make carbon dioxide and nitrogen. This is how a catalytic converter reduces the emission of pollutants. The solutions of transition metal compounds are often very colourful. Because of their bright colours, transition metal compounds are used to produce the vivid colours in pottery glazes. They add colour to the surface of the clay. To show the range of glazes, this potter is making some test samples. First, the fresh clay is moulded into shape. It's then fired to dry it out and prepare it for glazing. Next, the clay shapes can be dipped into glaze mixtures. These contain different transition metal compounds. The glaze coats the surface of the clay. Finally, the shapes are placed in a kiln for a second time and heated to a very high temperature. The result is an array of different colours provided by the compounds of different transition metals. And different compounds produce different colours depending on the type of clay that's used.
Let's start by doing some experiments. We have chosen iron and copper as the elements we will use for testing from the transition metals group. We will use the following forms of these substances in our experiments. For iron, we will perform tests on an iron nail, some iron filings and steel wool. For copper, we will test some copper foil as well as copper powder. We will start with iron. When you experiment with iron, it is important that you first clean the object that you're using by either dipping it in vinegar, which is a weak acid, or by scrubbing it with steel wool to remove the dull layer of rust that forms around iron substances. The iron nail is now placed in the flame of a Bunsen burner using tongs. Can you see any changes in the appearance of the iron nail? The nail glows red hot. When it is taken out of the flame, it looks slightly duller than before. This is because it has a layer of brown-black oxide coating it. When we sprinkle iron filings into the Bunsen burner flame, you will see the filings spark and burn with an orange flame. Let's clean a piece of steel wool by dipping it into methylated spirits. Now, let's see what happens when we hold it in the flame. The steel wool first sparks and then ignites with an orange flame while we hold it in the flame. It stops burning when we take it out of the flame. From these observations, we can conclude that iron does not burst into flame. It is far less reactive than the other metals that we have investigated so far. Do you think we will see similar results when we repeat this experiment with copper? Sometimes copper has a layer of lacquer coating it. This prevents the copper from reacting, so it must be removed with steel wool before we test the copper. When we place a strip of copper in a Bunsen flame using tongs, we can see that the copper strip glows red hot, but it doesn't burn. When the copper is removed, it has a black coating. This black coating is called copper oxide. If you look very closely, you should see that the flame of the Bunsen turns a green-blue color. This is a characteristic color of copper compounds. Copper powder allows a greater surface area of copper to come in contact with the flame. We place some copper powder on a combustion spoon and hold this in the Bunsen flame. Now you should be able to see this color change more clearly. From what we've seen, we can conclude that copper is even less reactive than iron, and it does not burn in the flame as iron does. Both these metals are less reactive than any of the alkali and alkaline earth metals. The outer layer of these metals reacted with oxygen to form the metal oxide, iron oxide, and copper oxide. The oxides are visible as the dark, dull discoloration seen on the metals when they are removed from the flame. Let's write the chemical equations for these reactions. The word equation for the copper reaction is copper plus oxygen reacts to form copper oxide. The chemical equation is Cu plus O2 reacts to form CuO. Check if this equation is balanced. There are 2 atoms of oxygen in the reactants and only 1 in the product. To correct this, we need to show that there are 2 particles of copper oxide formed as the product. We show this by writing a 2 in front of the CuO. Look again. Now the copper atoms are not balanced. We must have 2 copper atoms at the start of the reaction. You can show this by writing a 2 in front of the Cu. Now the equation is balanced and represents the chemical change taking place. Iron bonds with oxygen in a very different manner. The unbalanced chemical equation for the reaction iron plus oxygen reacts to form iron oxide is Fe plus O2 reacts to form Fe2O3. Why don't you try and balance this equation now? Here is a tip to help you balance this more difficult equation. When you have an even number of atoms on the left and an odd number on the right, multiply the odd number by 2. So I write a 2 in front of the Fe2O3. This means I have 6 oxygen atoms on the right and only 2 on the left. To balance this, I write in a 3 in front of the O2, since 3 times 2 is also 6. Now, finally, I need to balance the iron. This is easy. I have 4 atoms, 2 times 2 on the right and only 1 on the left. I write in a 4 in front of the Fe and the equation is balanced. I think you can see that even though transition metals are not very reactive, they still do combine with oxygen. Whenever these transition elements are exposed to air, a slow reaction takes place. But the end result is that the original metal is corroded away and we are left with a useless pile of metal oxide. This is particularly true of iron. Iron reacts with air and in time iron oxide or rust forms. This rusting reaction is really costly. Scientists have been doing lots of research to prevent and slow this reaction down. In today's task, I want you to see if you can find out more about this rusting process. Plan and conduct an investigation to determine the factors that affect the rusting of an iron nail. Before you start this task, you need to identify some factors you think may affect the rate of rusting. Do things like temperature, the amount of water, or the presence of salt water have any effect on rusting? You will need to select one of these factors and then design a test. Also remember to make sure that your test is fair by controlling variables not being tested. Remember to record your results, draw conclusions, and be ready to communicate your findings to the rest of the class. I really hope that you enjoyed doing today's task, and remember to represent any chemical changes you observe as a balanced equation. In our next